Okay, we now assume that all the exogenous variables in the monetary approach to the exchange rate are constant over the time. So our first assumption is that omega t are equal to omega 0 for each t. This implies that according to the definition, to the assumption we need to impose in order to avoid explosive or implosive path for the exchange rate, we need to set the exchange rate as its base by fundamental, which is the integral between Tn plus infinite or omega v, where omega v is a combination of the exogenous variables in the model, 1 over alpha 2 e to the power minus v minus t over alpha 2 in the v. Now this is equal to 1 over alpha 2 integral between t and plus infinite. Omega 0 is constant over the time. We consider also e, we split the exponential as e to the power t over alpha 2, which multiplies e to the power minus v over alpha 2 in the v. We can put outside the integral this part, which is outside, which does not depend on v, which represents time in this integral, and we get 1 over alpha 2 omega 0 e to the power t over alpha 2 integral between t and plus infinite e to the power minus v over alpha 2 in the v. This integral, so we get 1 over alpha 2 omega 0 e to the power t over alpha 2. This integral is minus alpha 2 e to the power minus v over alpha 2, but we need to compute this integral between t and plus infinite. So we get 1 over alpha 2 omega 0 e to the power t over alpha 2, and when v goes to plus infinite, given to the fact that here the exponent is negative, the integral is 0, minus the value in t is minus alpha 2 e to the power minus t over alpha 2. So we get alpha 2 and alpha 2 simplifies, this and this simplifies in the sense that it gives 1. The final result would be that if the exogenous variables are equal to constantly equal to omega 0, also the exchange rate, which is the discounted value between t and plus infinite of these fundamentals, will be equal to omega 0. Now, we can suppose that we have an increase in nominal money stock. So our first hypothesis of monetary policy, because it is the monetary approach to exchange rate, so we are interested in hypothesis about monetary policy is that MT becomes equal to M0 plus epsilon. So the initial stock, nominal stock, plus a percentage epsilon for each t greater or equal than t0. This is a sudden and permanent increase in nominal money stock. We mean that is the money stock respect to time until t0. The nominal money stock is m0. Suddenly and starting from t0, nominal money stock becomes m0 plus epsilon. So what is the dynamic in the exchange rate? In order to simplify, we can suppose that before t0, all the other exogenous variables in omega are equal to 0. So the only variable affecting the nominal money stock, the other exogenous variable is the nominal money stock, which is equal to M0 before T0. And what is the dynamic in the exchange rate? In order to find the dynamics in the exchange rate, we need to solve the integral between t and plus infinite of the new nominal money stock. All the other exogenous variables are equal to 0. So we are assuming that P star is equal to 0, I star is equal to 0, consumption is equal to 0. All the exogenous variables are equal to 0 in logs these three variables, and also the foreign exchange, the interest rate is equal to 0. So we need to solve this integral e minus v minus t over alpha 2, but we know the value of this integral because it is constant over the time, this permanent, so this value is m0 plus epsilon from the previous integral with omega 0 we have found before. So this value of the exchange rate, the dynamics of the exchange rate is the following. Until t0, due to the fact that this time, due to the fact that the exchange rate is permanent equally to m0, the nominal money stock and all the other exogenous variables are equal to 0, exchange rate is equal to m0. Due to the fact that in t0 you have this increase in nominal money stock, also the exchange rate jumps by the same percentage and continues to have this dynamics. Why we have this? We can also understand the economic intuition behind this dynamics, and the reason is that in T0 the nominal money stock increases by epsilon, but if we have at the same time an increase in the exchange rate by the same amount, the real money stock MT minus PT, which is given the purchasing power parity is given by MT minus foreign price minus the exchange rate in log, but this is equal to 0, my assumption, implies that if the nominal money stock increased by percentage epsilon, the nominal price increased by the same level, the real money stock does not change, so there is no change in interest rate and no further change in the exchange rate. So in order to maintain the equilibrium in the money market, the nominal exchange rate jumps by the same percentage of the permanent sudden increase in nominal money stock.